Chapter 29 Generic Spell Interface Intent. We originally wanted the player and his enemies to have the same abilities, and to play by the same rules. We've been straying in that regard lately. The player has no access to debuffs, and the monsters can't teleport, heal, or shoot. We also hinted we lack a way to refer to any given spell. We circumvented this in the previous chapter by switching on the object type and then manually creating our spell commands one by one. We will now address these things by making a kind of spell factory and an enumeration naming all our spells. This spell enumeration. Behold the enumeration 04 commands 29 spell TS. We've not given much thought to the power ordering of our spells until now. We intend the dungeon and its monsters to get more difficult as we delve deeper. It follows that the early spells should be weaker and the later spells more powerful. Thus I have sorted the spell enumeration above in an approximate order of power. I've also tried to mix and shuffle the different kinds of effects, so we don't, for example, get 3 slowing effects in a row. We want the player to find more powerful items deeper in the dungeon, so the later spells should only appear on items found further down. The plan. To make our enumeration work, we'll make a factory class with a method that switches on all its possible values, and construct commands for each of them. Is that all we need? Well, no. Earlier, the sap spell required us to employ the command direction screen. We face something similar here. For the monsters, we need code to decide how they should use the spell. If they use the sap spell, it must target their aim in a reasonable manner. We may hope they may sometimes shoot their friends with so-called friendly fire. If they cast heal, maybe they could heal allies instead of just healing themselves. How should the player cast debuffs? It could work in many ways, for example targeting the nearest enemy, or allowing you to choose a target. We will simply make them missile spells, so that you shoot a debuff like a projectile. We must also design how our item spells should be distributed. Earlier, we had a separate item for each spell, but with 24 or more spells, that becomes tedious. Instead, we'll put a spell field on the object class. For now, armor and weapons should not have spells on them. Though there is an idea in having magic armor which confers magic abilities, we don't want to do so simply by putting any spell value directly on a helmet. As in the item effects chapter, it makes sense for potions, scrolls and wands to have spell effects. Naively, we could combine all of them with all spells. Alternatively and traditionally, potions, scrolls and wands have effects divided between them. Wands would mostly be aimed projectile spells. They might hold our debuffs. Potions would affect the drinker, and the drinker's body in particular. Scrolls would be any sort of other magic effect. For now, we'll go with any spell for any item, but the above idea still has merit. Player spell access. We will first complete the player's spell arsenal. To help with this, we'll give the player a spell menu screen, so we can test our spells, the 29 spellscreen.ts. We'll let the screen replace the earlier bullet command in the passkey command function in 09 passplayer. So when you press M, you now get a whole menu of spell. Then we must implement that spell finder, which the screen used. This entails providing the player's missing spell commands, notably his debuff spells, which will take the form of missiles. Because of how we originally made the missile command, it's a simple matter of plugging in a configurable blast step, which applies a debuff instead of damage. In the code below, this is handled by payload command. So 29 spellfinder.ts, similar to our earlier find object spell. We saw a couple of new spells in there, so let's implement them. The 29 multiply command.ts looks like this. And built on top of this, 29 summon command.ts. These spells are really intended for the enemies to use, but as we are making a unified spell interface, we will make them generally available. Multiply makes monsters breed, that is, the monster clones itself, and then those clones also clone themselves. Summon instead summons similar level monsters. On the one hand, it might be less dangerous when those spawns don't multiply. On the other hand, those spawns might be dangerous by being higher level. The player can cast Summon if he really wants to. In fact, he can also cast Multiply, but we probably shouldn't let him do that. And now we must account for the payload command. It accepts an inner payload, which it will execute if it hits. That part is done by the payload step. And it is just a slightly modified version of blast step. Thus, the payload command simply lets us provide, for example, a buff command to be executed when the missile hits. With spell screen and the spell finder in place, we've taken care of the player. He can now execute any spell, at least for testing purposes. Item spells version 2. Once we've made sure they all work, it's time to integrate the spells with our items. It's not all our items that spells make sense for. At least for now, our armor shouldn't trigger spells. Instead, we'll mainly hook them up to potions, scrolls, and wands. We'll not distinguish greatly between the different item kinds. But we should maybe make wands rarer, since they're most useful and powerful. We will tie the spells to levels, so spell N is most likely to appear at level N. Note that right now, weak spells will not appear on deep levels. This could alternatively be changed, so dungeon level N would contain items from any level between 0 and N. We can start by adding the attribute spell to object. Then, in make template command in object types, we add these bits. We must then change the find object spell to respect this new setting in find. So we rename the old find method to find28 and make a new find29 that instead follows object spell. Rare wands. We can make wands rarer by changing 21 object types.ts like so. It works this way. We pick random templates the same way we used to. But whenever the template picked is a wand, we do an extra probability percentage check. If that check fails, we loop back and try to pick another template. On the low starter levels, we will only have a few percent chance to get a wand. But as we approach the deep levels around 30, wands should appear as often as other items, that is around 90%. We've hooked the rare wands method into the existing random level object method, so anybody using the latter will now instead get the services of our new method. Distinguishing item qualities. We could consider disguising the various spells behind physical attributes, like colors. This is normally used for scrambling in identification systems, but we might choose to instead keep the colors the same each time. We could do so either by fixing the random number seed we use for scrambling them, or by just not scrambling them at all. Now, about those colors. The basic idea is to have a color for each kind of spell. So let's make ourselves an array of colors. Behold, 24 colors for 24 spells, 29 color.ts. The reason each color has 2 items is in case we want a color name that HTML doesn't know about. Then we could put the HTML color in the first item and the display label in the second. For now, we've only used names HTML knows about. Inside the innermost loop of drawMap18, we add this bit. It says that if the cell has an item and that item has a spell, we'll color with that instead. We can do even better. In object.description, we can do this. So when we look at a spell item, it will say things like Crimson Potion here. If you don't like using colors for this, you can instead use the proper spell name with this line instead. Updating the builder. As we added the spell property to object, we added it as a third argument to the constructor. To be fair, we should introduce an updated builder to match this. We clone 28 builder 2n to 29 builder 2o and make index 29 enumeration spell as a runner. Then we can fix 29 builder 2o so all its new object constructor calls include the spell, for example like this. We don't have to update it everywhere else though, since we wrote the constructor with the default. Enemy spell access. With find spell, we've taken care of the player, but we must also make it so the monsters can use all spells. That will be the class NPC Spellfinder. Though it will work in a similar way to find spell, it must calculate and pick sensible arguments for the monster spells, instead of pushing input screens for them. However, the NPCs might still push screens, namely if they try to cast missile spells. For most spells, we can simply instantiate their commands, similarly to how Find Object Spell and Spellfinder did it. Behold, 29 NPC Spellfinder. You may recognize this code as mostly identical to the player's Spellfinder. The danger in having two is that we have to update them symmetrically. If we were to combine them, we'd only need to maintain a single copy. Here I opted to keep them separate, to keep the code cases simpler. You've been warned. These shooting AI. Now that NPC Spellfinder offers us a bigger selection of spells for the NPCs, it's time to make an updated spell AI. We clone the old spell AI 24 spell AI and modify it to pick from the new spell enumeration instead of just from the debuffs. We'll handle the NPC missile spell separately. A bit like the player, NPCs can only shoot diagonally and in straight lines. With a basic NPC spell, they would almost never shoot. Because of this shot of opportunity mechanism, NPCs should track if they can shoot and decide directly. Our AI must therefore check if the monster is lined up with the player. If it is, and if the monster uses a missile spell, it should fire on the player n% of the time. Other spells will use the normal spell rate we've used so far. From the player's perspective, he could act based on the rate at which NPCs will shoot. That is, if they're inclined to take every opportunity shot, it would be unwise for him to give them that opportunity. So that NPC monsters can trigger animated spells, we must extend the AI turn interface with the screen stack and the maker. It unfortunately requires updating the turn signature in all these files. The signature change for turn looks like this. And in base screen, NPC turns must pass stack interface to the NPC turn method. Our new AI will look something like this. Did shoot is the most complex part of that change. Its aim rule is a quick check whether the two monsters are on a straight or diagonal line. If they're not, we immediately exit did shoot. We start with this because it's false for most monsters and thus an easy way to avoid doing further work. Next, we check the monster's spell type, because this also is both a quick thing to check and falls most of the time. Again, if it's not a missile spell, we can leave did shoot. Next, we check the monster's chance to shoot. Again, a fast check. If it's not in the mood, no need to check further. Lastly, we reach the expensive can see check, which we have thus managed to avoid most of the time. If we can't see the enemy, again we exit. If we reach the end, we know both that we can shoot and that we want to shoot, so we shoot. This is the bit where we need to mess with screens. We're going to animate the NPC shot, so we'll push a stepper screen, the same that animates them when the player shoots. Once his shot has finished playing out, we need to get back to the game loop. That is, we need to continue running the NPC turns loop. On the face of it, that doesn't seem so tricky. When the player was shooting, we could finish up his turn by running NPC turns. So the same thing would happen at the end of the NPC's shooting animation. But as that NPC turn's call is executing, what happens if another NPC then starts shooting? Let's think through that scenario. Will the stepping screen still be on the stack or not? Will something take care of popping it? If we pop the current stepping screen before we let NPC turns run, it should work just as intended. We can make NPC Spellfinder handle the missile firing part with this code. The aim method figures out the direction between the monster and the player, which then becomes the movement direction for the shot. Hopefully, the monster will only shoot when it's aligned with the player in one of the 8 major directions. If a bug causes it to shoot anyway, it will do a badly aimed shot that will miss. Note that shoot is really just cast spell, but we like to use proper names, so our code tells the story of why we do things. To bring shoot AI into the game, we add this to mood AI, which we can use in the new builder. If we now try to run the game again, the enemies should run amok with a totally new spellcasting engine. Some of them should teleport, some should multiply or summon, and some should shoot. We did not make any monsters heal each other, but that's still a good idea too.